Welcome back to section 3.5 in Math 95. We're going to continue talking about equations of lines. We've already talked about using the slope-intercept form of a line to write the equation of a line. We've graphed a line using its slope and vertical intercepts. And then we've also used this new thing called point-slope form to write the equation of a line. We did that once or twice. We're going to do that a few more times in the next few slides before we get into writing equations of vertical and horizontal lines and then talking about parallel and perpendicular lines. Again, we're going to be using some information that we worked on back in section 3.4, so you might rewatch those lecture videos as a refresher if you're not certain where we're going. So we would like to use point-slope form to write the equation of a line from its graph. And we are wanting to write the equation in standard form. You may remember that that is going to look like ax plus by equals c. So that's our goal. Now, in order to use point-slope form of the line, we need the slope and we need a point. To get the slope, we need 2 points. So let's find our slope, and we can use one of the points from our slope to also use in point-slope form. So to find the slope of my line, I want to pick two really nice points on my graph. When I say really nice points, I'm talking about points that kind of cross right at the crosshairs, right at the intersection of those two grid lines. So I like this point. And then another good rule of thumb is your next point should be really far away. I don't want to use this one right here. That's not going to give me a very accurate representation of what's happening with my line. I'd like to use one of the intersections that's quite a distance away. So I could use, I could use this one. I could use this one. There are several that I could use. But notice, since I have many options, my solution might be a little bit different than yours. So keep that in mind as you are looking at these graphs that we've created on the internet or on a digital copy. It's really difficult to get lines to line up where you would like them to. So I would like to identify the points that I have. This one over here, its x value will be 1, 2, 3, 4, 5, 6, 7. That's a -7. And then its y value looks to be a +5. And again, this is approximate because we are looking at a graph trying to come up with these points. This one over here, its x value looks like it's a +7, and its y value is a -1. So these are the 2 points that I'm going to use when I am using my slope formula. So let's talk about our slope formula. That was our m equals y2 minus y1 over x2 minus x1. So for us, that will end up being our y2 and x2 could be this point over here. That's fine. It doesn't really matter. Our negative, I wrote that completely wrong. We're going to do a 5. And then I'm going to take away this other y value here. So that's a -1. And our x values are going to be -7, which corresponds to the 5. Those two have to match up. And I'm going to subtract 7 from that. With a little bit of arithmetic, 5 minus -1 is 5 plus 1. That gives me a 6. -7 minus 7 is not 0. It's -14. And now I'm going to reduce this. So we have m equals -6 over 14, which is actually -3 over 7. And using the reduced form, the simplified form, will make this a little bit easier. So we have gotten our slope. And now we want to use one of our 2 points to plug into point-slope form. So again, I'm just going to use the -7, 5. So let me grab a different color. Point slope form was the y minus y1 equals m times x minus x1. And remember that y and x are our placeholders for our variables. The y1 and the x1 are the coordinates of one of our points. So at this point, I'm going to plug in my slope and one of my points and continue from there. So I'll grab a different color just so we can see this. Y minus, I'm going to use this one, so y minus 5, should equal my slope, which is negative 3/7, times x, and x is going to be subtracting this negative 7. I'm going to just work through the algebra here. Y minus 5 is going to equal negative 3/7 x. And then I've got a bunch of negatives here, so x minus negative 7, that was a positive. And then times negative 3/7. I'm going to do some magic here. This is going to wind up being just a minus 3. So, as I continue on, I'm going to isolate y. I'm going to add that 5 to both sides, so I get a negative 3/7 x. I add 5 to both sides, I get a plus 2. Now I want to look at our line and see if this makes sense. I am told that I have a vertical intercept of a positive 2, that looks about right, and a slope of negative 3/7. The negative makes sense because the slope of this line is decreasing, and the 3/7, if I start here and go down 3, 1, 2, 3, 4, 5, 6, 7, I look to be right back on that line. So all of this is looking great. I'm not finished though, because I wanted to get into standard form. Anytime you feel like you're at a stopping point, it's good to reread the question to figure out what you were actually asked to do. So to get this into standard form, I need my x and my y on the same side. So first I'm just going to add my x over, and I'll do this in a different color. This looked good, now we want to write it into standard form. So we're going to put this into the ax plus by equals c. I add my x over, and I end up with 3/7 x plus y equals 2. But remember, one of the qualifications of standard form is that a, b, and c have to be whole numbers. I have to turn this fraction into a whole number, so I'm going to multiply everything by 7. This is going to leave me with 3x plus 7y equals 14. And that is the equation of my line in standard form. Now I could check this, and I should. And I'm going to check it by plugging my other ordered pair into this equation to make sure it's still true. So let's just check it really quick, and I'll do that in a different color. 3 times 7 plus 7 times negative 1, that looks like a 7, should equal 14. We get 21 minus 7 equals 14, and that's true. We like checking because it doesn't take very long and it tells us we're right. So make sure you're doing that often. All right, let's move on. I would like to write some equations of vertical and horizontal lines. So we need to remember what those equations look like. If I want to write the equation of a vertical line containing this specific point, so we've got a vertical line containing this point, I need to remember what the equation of a vertical line looks like. And we talked about this a couple sections ago. If I have a vertical line, I look at my axes here. So just do a quick sketch. Here's my y, here's my x. If I have a vertical line, that means that its horizontal distance from the y-axis is always the same. In other words, its x value is always the same value. So the equation of a vertical line is always x equals some constant. Now, if I'm given a point, I know what that constant has to be. In our case, this x value is going to be this negative 1. That is the equation of a vertical line. A reminder, the slope here is undefined. I have no run. My x value is always the same, so my slope is undefined. If I want to write the equation of a line containing the point 4, 7 with a slope of 0, if my slope is 0, that means that my y value is always the same, which gives me a horizontal line. And if that y value is always the same, I can look at my ordered pair and pick out the y value that I have. Let me try to make that a little bit better. There we go. So for us, y is going to equal 7. Just a heads up, if I wanted to write the equation of the line containing this point perpendicular to the one that I already did, it's going to be the vertical line. So horizontal and vertical lines are perpendicular to one another. You'll see that often in your book. They will ask you to find the equation of the line perpendicular to x equals -1 that passes through a specific point. And so that's going to be the horizontal line, in other words, the y value of that point. Okay, speaking of parallel and perpendicular, let's see what that looks like. If I wanted to find the equation of a line containing this point parallel to this line, parallel, I want to also write the equation in standard form. So we first need to figure out what parallel means. Parallel means same slope. So to begin this process, I want to be parallel to this line, which means I need to find the slope. Which means, all of these implications, this means I need to get this into slope-intercept form. It's almost there, but not quite, so let's get it there. I have the line 3x plus y equals 5. This is standard form. To get it into slope-intercept form, I'm going to subtract 3x from both sides. So this is going to turn into the line y equals a negative 3x plus 5. And so my slope here is -3. That means the slope of my second line is also going to be -3 because I want to be parallel. Now I have a slope and I have a point. It's a -1, 2. So again, we are going to use point-slope form to get the equation of this line. So I've got my y minus y1 equals m times x minus x1. That's my form. And now I'm going to fill in the pieces. Y minus my y value is 2 equals my m, which is -3, times x minus -1. Do a little bit of simplification. Y minus 2 equals -3x. Count my negative signs again. This x minus a -1 makes this inside here a +1, and it's being multiplied by a -3, so I get a -3. Now, I would like to get this in standard form. I don't need to get it into slope-intercept form. So I am not going to take that middle step. We're not going to go into slope-intercept form. Instead, I'm going to add my 3x's to both sides, and I'm going to add my 2 to both sides. So at this point, I will have the equation 3x plus y equals -1. And that is me in standard form. And I'll remind you that that is ax plus by equals c. Parallel means same slope. I could also do this if I wanted to find the equation of a line containing a point perpendicular to another line. So we will do that on the next slide, if I planned this correctly. Perpendicular, all right, keyword, that's the one we're going for. It asks for a function, which means we want this in f of x equals mx plus b, so that's our function notation. In other words, slope-intercept form. So again, we have a point, and we have another line we're working with. And so I need to find the slope of this line before I can do anything else. So we're going to find slope of that guy, which means get it into the slope-intercept form. So I have 2x plus 4y equals 5. Subtract the 2x from both sides. 4y equals negative 2x plus 5. And then I'm going to divide everything by this 4. So I get a y equals negative 2/4 x plus 5/4. You may be tempted to forget to divide something. Don't do it. It's really painful when you do. We are not finished. I'm going to simplify this slope. So I'm going to have the line really y equals negative 1/2 x plus 5/4. That 5/4 kind of got a little boxed in there. Let's see if I can move this over. There we go. That's better. So I'm going to call this slope m1. m1 equals negative 1/2. Something that I know is that I want the perpendicular slope. Perpendicular, I'll do this over here, perpendicular means I need to find the opposite reciprocal slope. So really what that means is I'm going to take this fraction, I'm going to flip it on its head, and I'm going to switch the negative sign. So if m1 is negative 1/2, m2 should be positive, and I'm going to flip the fraction. Instead of a 1/2, it's now a 2/1, and I could just call this a 2. A way we could check this is that m1 times m2 should equal negative 1. So if I take my negative 1/2 times 2/1, I should get a negative 1, and I do. That should be negative. Don't drop your negative signs. So now that I have my slope, and I have a point, I'm going to use point-slope form. Y minus y1 equals m times x minus x1. So that'll be y minus 4 equals 2 times x minus 3. Y minus 4 equals 2x minus 6. Y equals 2x, add 4 to both sides, minus 2. We were asked to write this in function notation, so my last step is just replacing that y with an f of x. F of x equals 2x minus 2. Now, there's not really any way to check this. Unfortunately, we were only given 1 point, so we can't really check this equation at all. Kind of have to hope you're right as you go. Just really quick to summarize what we've done so far. If you are asked to find this type of form of a line, this is your standard form. A, B, and C are whole numbers. A is typically positive. Y equals mx plus b is your slope intercept form. the easiest form from which to graph, because you have your slope and your intercept right handy. M is your slope, B is part of your vertical intercept, your y part. And then we have this crazy looking form. This is our point slope form. Which is really, really handy if we have to figure out the equation of a line from maybe 2 points or from a graph. Once I identify the slope using the slope equation, I can plug in one point with that slope and quickly get to either of my other two. These are the two forms of a line we typically have as a final form, and point slope form allows us to get either way fairly quickly. A quick reminder, I can also write slope-intercept form as f of x equals mx plus b. And another note, if I wanted to find m, that would be y2 minus y1 over x2 minus x1. We talked about y equals a constant and x equals a constant. Y equals a constant is going to be your horizontal line. The justification I have for that is we want our y value always to be the same thing, no matter how far left or right we're going from the origin, from that y-axis. Our vertical coordinate is always the same. So we're not moving up or down, which is why we get a horizontal line from there. And our slope for that is going to be 0. For x equals a constant, it means our horizontal distance from the y-axis is always the same no matter how far up or down I go. So I end up with a vertical line and an undefined slope. Talking about parallel and perpendicular lines, parallel lines have the same slope, and the product of the two slopes of two non-vertical perpendicular lines is -1. In other words, those two, so perpendicular lines have the opposite reciprocal slope. I mentioned this briefly a couple slides ago. If I want to find the slope of a line perpendicular to this, I need to figure out what that line is. So I'm going to try to isolate a variable. I get the equation x equals 4. This is a vertical line. Try that again. Vertical line. So the slope perpendicular to a vertical line means horizontal line, so m would equal 0. Conversely, if I have the equation y plus 3 equals 0, that means y is always -3. This is a horizontal line. So the slope perpendicular to that, m would be undefined. With that summary of lines and slopes, you should have everything you need to finish your 3.5 homework. Let me check to make sure we don't, yeah, we're at the end of the slides here. So if you have any questions, email me on the forum, and if nothing else, we will see you soon.